Section 3.1. We did skip chapter, whatchamacallit, 2. So what we're going to do, and we've actually mentioned this before, to tell you the truth. Oh, it's going to give me some color here. Okay. We've talked about things being parallel, haven't we? Okay, but we're going to really talk about stuff that's parallel. So parallel lines, okay, and here's a nice big word. You might have not used this before, but transversals. Transversals are really important when we're talking about parallel lines. Well, let's talk about parallel lines first. Somebody off just the top of their head, without looking at the book, without reading the definition from the book, just tell me what they know about parallel lines. Emily, tell me. Okay, they don't intersect each other. Good. Is there anything else you might know? Brooke? Yeah, pretty much. That's what they tell you, isn't it? They pretty much tell you they're lines that don't intersect each other, right? So what else is there to say about it? Oh, you looked. I told you not to look. You looked. Okay, but he's right. They have to be coplanar, which means what? The lines have to lie where? In the same plane. So what I'm going to do, I'm going to copy that. I'm not going to paste it. So it's the same exact, it's going the same exact way, isn't it? All right, because I copied and pasted it. Would you agree? So these two lines right here, they'll never touch each other, and they're in the same plane. All right, if they're in the same plane, they have to be in the same plane to be parallel to each other. All right, so these two lines right here are on that, whatever that black surface is right there. Okay, we'll consider that the plane. So those are in the same plane. They're never going to touch each other, so they're parallel lines. Here's what we do. You can put the arrows on the ends of here, but I'm going to show you how to show parallel lines just by looking at it as far as the picture is concerned. I'll do this in a different color. And I might even do it a little bit thickerer. Used to be a commercial. Probably never remember it, do you? I forget what it was. It was peanut butter or something like that, and the kid would say, "It's thickerer," and everybody would, back in the day, how you always emulate commercials and you say stuff that people say in commercials. Kids would say that all the time. It's thickerer. So I don't know. It just came to me. Just came to me. All right, watch. If I put, now I made these a little extra big, but I put arrows on here. Now, it's not talking about the arrows on the end, okay, because that just represents their lines. But if I put arrows somewhere in between, it could be right in the middle, they could be on the edge, something like that. I did them in a different color just so it stands out a little bit. But if you put arrows in there, that indicates that these two lines right there are parallel to each other, okay? So let's name this. Let's call that line L and line M. All right, we won't use them by points. We'll just say this is line L, line M. If I knew that if I had the arrows on both of those, that tells me that those two lines are parallel to each other. This is how we would write the lines parallel. Put L is parallel. It should be about the same length. Okay, parallel. I still didn't do it right. Come on. Boom. That's a little short. Dang on it. Why can't I do that? That's all right. Close enough. This is as close as I'm going to get. All right, so that the little two up and down arrows kind of looks like an 11, but they're two up and down lines right here. That means parallel. It means they're parallel to each other. So this means line L is parallel to line M. Everybody with me on that? Pretty easy, isn't it? Yeah. Now remember, they have to be in the same plane. Now, there's a picture in the book. I'm not going to draw this or try to draw this out. If you look on page 171, we talk about what if two lines are in different planes but they never touch each other. For instance, let's use these two, this folder and this notebook right here. These would represent two different planes. Get some pens here. Put one pen on one plane. Put one pen on another plane. We go like this. Now if I held these like this, okay, or let's say I went like this, okay, they're never going to touch each other. All right, but are they parallel lines? Look, the line, see the red pen? Can you see it? It's kind of facing towards the bookshelf. This blue pen is facing towards the window. Everybody see that? So they're not really traveling in the same direction, are they? Those two lines. But they never touch each other. All right, so if they never touch each other, then does that mean that they're parallel? No. It's only if they don't touch each other and what else? And they're on the same plane. Right now they're not on the same plane. Now if I did this, if I put the two pens right here, and they were side by side like this, going in the same direction, one wasn't tilted towards the other one, then they would keep on going forever. They would be in the same plane. Does that make sense? So they would be parallel to each other. What if I did like this? Just put it up like this. Are those two lines parallel to each other? No, again, because look, one's going this way, one's going this way. On the YouTube, you can't see what I'm doing, but that's okay. So these would not be parallel to each other. We have a word for this. We don't use this word very often. We're really stick with parallel, but just so that you know that these two lines, if they don't intersect, but they're in different planes, they're called skew lines. S-K-E-W, skew. All right, it's kind of a funny name. Skew lines. So they're lines that don't touch each other. Okay, they'll never intersect. That's a better way to say than saying they don't touch each other. Okay, they don't intersect. All right, but they're in different planes. Now I'm not going to draw that out here, but here's the word. Yes, the word skew. So sometimes they'll say, name two skew lines, and you just have to know what that means. All right? Does that make sense? Like a box. I tell you what, let's get a box. All right, here's a nice box. Let's take a look at this and find out which lines are parallel and which ones maybe are skewed to each other. I'm not going to take the time to put all the points in here. What about this? I don't know, let's do it. I think it'd be a lot easier. We'll call this one E, A, B, C, D, E, F, what? G, and then H. Yeah, it didn't take too long. That's an H. I know it kind of blends in. Did I get everything? Yeah. Okay, give me a line that's parallel to line AB. HG, good, because it would be in the same plane. They were still in that top part of the box, right? So they're in the same plane. They're not going to touch each other. Good. Give me another line that's parallel to AB. CD, right, because it's on this side face right here, isn't it? So it's in the same plane. They don't touch each other. They don't intersect. That's a better way to say it. Okay? What do you think? Say what? Two different planes? The points A and B? Or what do you mean? Or line AB? Yeah, line AB could, sure. I mean, a single line could be in an infinite number of planes. But yeah, so AB could be in this top plane, right? And it could be in the side plane as well. Sure. What do you think, Alex? It's a good question. As long as you consider the plane that they're in kind of going diagonal through that box. He said, can AB and EF be parallel to each other? Well, sure they could, but our plane is not really shown in this box, though, are they? Okay, so let's just stick with the sides, the planes that we see in the box. But you're absolutely right. If I could diagonally show a plane, right, that cuts through the middle and they're on the same plane, sure, they could be parallel to each other, absolutely. Okay. What about this? Let's find some lines that are not parallel to each other. Let's stick with AB. With AB right here, find me a plane. Tell you what, let's make this a little thicker. Or find me a line that is not parallel. And we'll make this a different color. That's not going to help, is it? There we go. All right, Timmy, what'd you say? H who? A. H-A. Well, they wouldn't be skew lines, because remember, skew lines don't do what? Yeah, did I say? Oh, I'm sorry. Okay, yeah, if I would have, and I probably did say that. You're absolutely right. If I said lines that are not parallel, HA would be that, answer that question. Sorry, I misspoke. Let's find a line that is skew to AB. So would HA be skew to AB? No, because they do what? They actually intersect each other. Remember, skew lines, they don't intersect, right, but they also don't lie in the same plane. So give me another line that doesn't intersect AB, but lies in a different plane. HE? Yeah, HE, that'd be a good one. All right, right there. That doesn't lie in this plane at all, does it? Because look at AB. Lies in this top plane and this front face, doesn't it? HE lies where? On this side one, right? This back one right here and this side one right here. So they don't have anything in common. So yeah, they could be. What else, Alex? EC. Yeah, EC would be another one. Good. EC and AB would be skew lines, wouldn't they? You see any others? FD. Yeah, FD would be skew to AB as well. Make sense? All right. So that's the difference between skew and parallel. We're really going to concentrate on parallel, not too much on the skew lines. All right. So let's just talk about parallel now. And what was that other word I put at the beginning of this? Transversals, right. So I'm going to draw a couple lines. Oops, what did I just do right there? Oh, I know, I hit the wrong button. There we go. All right, here's two lines right here. And let's do this one another color. I'll tell you what. I'm going to purposely... Let's see if I remember how to do this. Yeah, there we go. I'm going to purposely make them so they don't look parallel, okay? Because what we're going to talk about right here, the lines don't have to be parallel for right now. Later on, we are going to do some things about parallel lines. But what I want you to do is I want you to see some relationships between some of these angles. Now, watch what I'm going to do. I'm going to mark some angles here. 1, 2, 3, 4, 5, 6, 7, and 8. All right, see all those angles that are marked? We have a lot of different names, a lot of different relationships for these angles, and that's what I want you to see. Now look at the two blue lines. I'm not going to say they're parallel because they don't look parallel. They would eventually intersect, wouldn't they? If that line kept on going this way and kept on going this way, yeah, they would eventually intersect each other. So right now, at this moment, we don't really care about these lines being parallel or anything. I just want to look at some names of some of these angles. Look at all the angles that are between the two blue lines. List them for me. What are the angles between the two blue lines? Yeah, 3, 4, 5, and 6. Okay, 3, 5, 4, 6, whatever order you want. Okay, those are all the ones that are between. But we don't say between. What we do is we say they're in the interior. Okay, they're in the interior of those two lines. That means they're in them. So if I have two lines like this, anything between those two lines are called interior angles. Everybody see that? That kind of makes sense, doesn't it? I got two lines. All the stuff in between are interior angles. What do you think? Wild guess, but what do you think about 1, 2, 7, and 8? They're exterior angles. Very good. Okay, so 1, 2, 7, and 8 would be considered exterior angles. You may want to jot those and list those out. 3, 4, 5, and 6 are interior. 1, 2, 7, and 8 are exterior angles. Okay, let's get a little bit more specific, and I will write these out. This next one they call consecutive. I can't spell. Let's try this again. Consecutive. There we go. Consecutive interior. I'll just put int for interior, or interior, and then I'll put the little symbol for angles. Is that all right? So consecutive interior angles. What in the world are consecutive interior angles? What these are? What's all our interiors? 3, 4, 5, and 6, right? The consecutive. And here's, I'll put this in like a parentheses. I taught out of another book, and I kind of like how the other book names it. And I'll just do this. You won't see this in your book, but I had another book that called these angles same side interior angles. I kind of like that better because it's a little more descriptive, I think. But this book calls them consecutive interior angles, and that's what we'll call them, all right? But it means the same thing as same side interior angles. So watch, 3, 4, 5, and 6. When I say the same side, oh, I almost forgot to tell you. Oh, my goodness. I drew this red line in here. I didn't tell you what that was. What's that red line right there? Not red lion, but red line. What is it? Parallels, and what's the other word to this lesson? Transversals, right. So this is a transversal. Wow, how could I forget that? Yes, it's a transversal, okay, because it cuts, it intersects those other two lines. So if you have a line that intersects two other lines, two or more other lines, we call that the transversal. All right. So I got my two blue lines, and that's why I made this different color. So this red one right here is called the transversal. All right. So now watch. Out of 3, 4, 5, and 6, which ones are on the same side of the transversal? Just the interior angles. Which ones are on the same side? 3 and 5 and 4 and 6. Okay, so let's list those. So angle 3 and angle 5, they're consecutive interior angles. And what are your other two pair? Or your other pair? Angle 4 and angle 6. Does that make sense? All right. So 4 and 6, because they're on the same side of that transversal. Don't you kind of like that name, same side interior, better? Because it describes them a little bit better. So 4 and 6 are same side interior or consecutive interior, and 3 and 5 are consecutive interior angles. We're going to learn something a little bit later, not today, but a little bit later. We are going to make these parallel in the next lesson, and we're going to talk about there's a relationship between the consecutive interior angles and these other angles that we're going to talk about, okay? So that's consecutive interior. Everybody good with that? Know which ones are what? So 3 and 5, 4 and 6. They're consecutive interior angles. All right. Let's do another type. Let's just write it out. How am I going to do this to keep that picture? Well, you've written all this stuff down, haven't you? I'm just going to erase it on my board here. But you can keep it on yours. Let's do another one. What do they have next? Okay, let's do this one. It's called alternate interior angles. So we're sticking with the interior angles for just a little while. It's supposed to be an R right there. Alternate interior angles. So again, the interior angles are 3, 4, 5, and 6, aren't they? What we want to do is we want to find the alternate ones. When you alternate, you're basically like skipping one. I don't know. I don't know a good way to explain the word alternate, but yeah, think of it as like complete opposite. Okay, so look at 3. That's an interior angle, isn't it? Which other interior is like its complete opposite? I would say 6, wouldn't you? Yeah, because look, 3 is on one side of the transversal, 6 is on the other side. 3 is up here up top, and 6 is down here on the bottom. Do you see that? So they're kind of complete opposites of each other. So we call those alternate interior angles. So you've listed 2 already, so angle 3 and angle 6 are alternate interior angles. What do you think the other pair would be? 4 and 5, right. Angle 4 and angle 5. So they would be alternate interior angles. And this is kind of important because we're going to learn some theorems tomorrow. We're going to learn some theorems that talk about relationships between consecutive interior angles, alternate interior angles, and a couple other things too. All right? So it's very important that you understand that. I'm not going to tell you right now what that relationship is. We'll figure that out tomorrow. But you need to know which ones are which. All right? So if I said 4 and 6, what would 4 and 6 be? What would the relationship between 4 and 6 be? Consecutive what? Interior angles. What about 3 and 5? Ah, tricked you, didn't I? Yeah, consecutive interior angles again. What about 3 and 6? Alternate interior, and of course, what would your other alternate be? 4 and 5, okay? So that's alternate what? Interior angles.
Can it also be like 1 and 8?
Well, they wouldn't be interior, though, would they?
Oh, okay.
Because 1 is an exterior and 8's an exterior. But that's a good observation, though, because that's exactly what we're going to do right now. And I'm going to shorten this. Instead of writing that whole word alternate, I'm going to put ALT. Is that all right? I wrote it out the first time so you could see the word, but alternate interior angles. In geometry, a lot of times I like to shortcut things, and I'll do that quite a bit. So, whoops, I don't want interior. What do you think I'm going for next? Exterior, exactly. So EXT for exterior, okay? So let's list the alternate exterior angles. So, yeah, so what are all 4 of my exteriors? 1, 2, 7, and 8, right? So what about angle 1? What would be alternate exterior with angle 1? 1 and 8. So let's write that down. So angle 1 and angle 8. And then what would your other pair be? Angle 2 and 7, right? It doesn't matter what order you put them in, but 2 and 7. They would be alternate exterior angles. Again, there's a relationship between those angles depending on your situation. But we're not going to talk about that today. We'll talk about that tomorrow. But you can't wait, can you? Find out what that relationship is. I can tell you're dying to find out. All right, here's another one. This is the last one we're going to do. This is called corresponding. 1 and 8 and 2 and 7. All right, so here's corresponding angles. When I say they correspond to each other, they kind of match up with each other. They're kind of in the same place. Kind of in the same place. Look at this. We've looked at the interiors grouped together. We've looked at the exterior grouped together. But look at this. I got like a whole section of 4 angles right here, don't I? And then I got a whole section of 4 angles down here. Do you see that? So look at this top. We'll call it the top section, bottom section, for lack of a better term. So look at angle 1. Which angle down here do you think kind of matches up with angle 1? Angle 5, yeah. Because look at these 4. This is on the top left-hand corner, isn't it? Of this group of 4. What's on the top left-hand corner down here? Angle 5. So 1 and 5 kind of match up with each other, don't they? Now look, one's a exterior, and one's an interior. So we don't call them anything interior or anything exterior, do we? But we do call them, what do you think? Corresponding angles, that's right. So angle 1 and angle 5 would be corresponding angles. Basically because they're in the same spot as the other one. Make sense? Let's list some more. Angle 2. Which angle down here would correspond to angle 2? Angle 6, good. And what would another one be? Angle 3 and 7. Good. And then the last one, angle 4 and angle 8. Does it make sense? Those words aren't too hard, right? It's just nice to see the relationship between those angles. And it's really important because we're going to use these words quite a bit. Not just in this chapter. We're going to be using them a ton in this chapter. But even as we go on, every once in a while, I'll come out and I'll say, hey, remember, they're corresponding angles. Or what are those angles? They're alternate interior angles. You're going to know just like that by looking at them, because you're going to do these so much, I hope, that you'll know the difference between them. All right? I think that's about it. How's that? Got it done pretty quick, didn't we? All right, so what do we got? Section 3.1. And we're going to do, get my little homework book here. Page 174. Well, we skipped chapter 2, right? And so we're going to go 13 to 36. Oh, man. It's really easy. For the most part, you're just going to look at the picture they give you and just tell me the relationship between those angles. Okay? Or they could do it two ways. They'll say, you know, tell me of the corresponding angles, or they'll say, here's angle 3 and 5. What's the relationship between those two angles? And you tell me. They're corresponding. They're alternate interior. They're alternate exterior. They're consecutive interior. All right? Whatever they are. So that's supposed to be a 4. That's kind of weird looking, but that's 174. 170. I just said it. I said it's supposed to be a 4, and then you said, what's that? So 174. Oh, okay. I'll make it look a little bit better. So 174. There we go. All right, have fun with that.